Hi all, welcome to Unshackling Sudokus and Puzzles. I'm Kishore and I'm here to solve a killer Sudoku created by Memeristor. I came across this killer Sudoku yesterday in the CTC Discord server and I noticed this comment by the author which said that this is a very hard killer Sudoku. So I thought of giving it a shot yesterday and I found this really excellent. If you have strong killer Sudoku basics, then definitely this should serve as a very good challenge. And it was so much fun to solve, and I really enjoyed solving this killer Sudoku. And I thought of making a video on this Sudoku for you. Hopefully, this video is enjoyable to you. Before watching the video, I would recommend to give this Sudoku a try so that you understand how it works. The link to solve is in the description of the video. Please do give it a shot yourself and come back and watch the video. And we thank Memeristor for allowing us to make a video on this Killer Sudoku. It is an excellent one of the best I've solved in recent times. So the rules are simple. Each row, each column, and 3 by 3 box of the grid will have digits 1 to 9, no repetitions. In all these dotted cages that you see, the sum of the digits will be equal to the clue given in the top left corner of the cage. This is true for each and every cage in the grid. And digits do not repeat inside cages. So for example, if you take this cage, you can't put 3 and 3 here because digits are repeating. So these are the rules, normal killer Sudoku rules. And with that, we'll start this Sudoku. I'm so thrilled to make this video for you guys. It was such an enjoyable Sudoku, so much enjoyable. So I said during my introduction that if you're strong at basics of killer Sudoku, this should serve as an excellent challenge. You will understand why I said that. So look at this 27 cage. A 27 cage with 4 digits, with 4 distinct digits, must always have a 9 in it. Because if not, the maximum sum would be 8, 7, 6, and 5. Which would only give 26. So we are sure that 9 must be inside the cage and 9 would have to go here because of these 9s. So let's now look at the other boxes to see if we can get anything. Look at this 28 cage, just symmetrically opposite to this cage. A 28 cage is even higher than 27 by 1. So which means that when it's made of 4 distinct digits, 8 and 9 must definitely be inside the 28 cage. Imagine making a total without the 8, for instance. The maximum sum you would get is 9, 7, 6, and 5, right? And if you add those, we arrive at 7, 6, 5, which is 18 plus 9, which is 27. You can get only 27, right? So 9 and 8 must definitely be inside the cage. 9 goes here and 8 would be in these 3 cells. Okay, the next thing we need to look at, okay, we can use some classic here and mark 9 in row 3. 9 goes in one of these cells, and similarly 9 goes in one of these 3 cells. Okay, anything else basic that we can mark here? So we know the 28 cage is now the remaining 2 digits must be adding up to 11 because 9 plus 8 is 17 and we need 11 more. So that is not 2, 9, 3, 8. So it's 4, 7 or 5, 6. So we'll remember that for now. 4 plus 7 or 5 plus 6. And now coming back to this 10 cage. So you will notice that so far I've done nothing but just write certain digits which are surely inside cages, which are surely going inside cages. Look at this 10 cage. A 10 cage with 3 digits must either have a 1 or a 2 or both. Without a 1 or a 2, there is no way possible to make a 10 total. So if you don't have a 10, a 1 or a 2, the minimum sum becomes 3, 4, 5, which is well above a 10. So which means that 1 must be surely inside these cages, right? And 2 is outside. So which means that the 10 is now, we need 9 more. So it's 136 or 145. That is the only possibility. Let me write that. 136 or 145. And remove this 1 because it's kind of distorting the clue here. Even here I noticed that this 28 is not seen properly. So let's make it 478 or 568, right? and we will remember that 8 is surely inside and 1 is surely inside here, right? Now here is where the Sudoku gets really tricky. So at this point, I spent a sizable amount of time. It was not easy to find the continuation. I was looking for all sorts of things. I was even asking if maybe fistomefal ring is going to be present here that we have to use. But then I understood how it works. Look what happens if 9 is in one of these two cells, right? That is the idea, and that is the break-in to this beautiful Sudoku. So if 9 goes inside the 16 cage, the only way to fill the 16 cage now would be 1, 2, 4 and 9. There is no other way, right? The moment 9 goes inside, we need 7 more from 3 cells. So it becomes 1, 2, 4 and 9. Now 2 gets, okay, 2 is inside this box, 1 is inside this box. And now look how you can satisfy this 17 cage, right? We do not have 1 and 2 inside the cage. And why is that the case? Because you have 1 here and a 1 here. So that removes, that fulfills your quota of 2 ones for column 4 and 5. And similarly, you have a 2 here and you also have a 2 in this box, which fulfills your quota of 2 also for these 2 columns. So the minimum sum you can get from these 4 cells is going to be, excluding 1 and 2, which is 3, 4, 5 and 6. And what happens if you add all those? You get 18. Beautiful reduction. A really, really beautiful reduction. So which means that you cannot have 9 inside this box, because that would force 1 and 2 in columns 4, 5 into boxes 2 and box 5, and 17 total would be without a choice, right? So 9 is not inside the 16 box. Oops. 9 would have to be here. And now the 9 in box 5 goes in these 2 cells, and the 9 in this box goes into these 2 cells. A very nice reduction, to say the least. And now using some classic, we know that the 9 goes in box 6 into these 2 cells and box 4 into these 2 cells. Okay. So now look at this 17 cage closely. I hope this is visible. The total is 17. You can see here. So we need 8 more from 3 cells, right? 9 is already inside the cage. We need 8 more from 3 cells. And 8 more from 3 cells can only be achieved in 2 ways. 1, 2, 5 or 1, 3 and 4. And in both the ways, 1 must be present inside the box. So we can erase this 9 and write 1, 2, 5, 9 or 1, 3, 4, 9. So 1 and 9 are surely inside. That's what we need to remember. Now, we already deduced that 1 must be inside this 10 cage, right? If you remember, without the 1, 10 cannot be achieved. And 1 is also in this box. So which means that the 1 in box 2, or rather 1 in column 6, must be in these 2 cells only. It cannot be here. It cannot be here. So 1 goes here. Now we got a big deduction. The 16 cage does not contain a 1. This is a really interesting deduction. Can it afford to not have a 2 as well? So the minimum total becomes 3, 4, 5, 6 without the 2. And you will see that the total is 18, which is 2 more than 16. So 2 is definitely inside the 16 cage, right? The moment 1 got excluded, 2 was forced inside the cage. And now you know that there is a 2 in column 4 and column 5. So the 8 is not 1, 2, 5 anymore. What a deduction, guys. Amazing killer Sudoku. Really, really nice. So the 8 becomes 1, 3, 4 and 9, right? It cannot be 1, 2, 5. So it is 1, 3, 4 and 9. So we have established the contents of this box. Now, okay. Now we also know that this 16 must have 14 from 3 more cells, because 2 is already inside. Can it afford not to have a 3? If it doesn't have a 3, the total becomes 2, 4, 5, 6. And if you add them, the minimum you will get is 17. So definitely 3 also must go inside the 16 cage, right? And look at the interplay, guys. Beautiful interplay. You have a 3 here. You have a 3 in this box. So you have got your quota of 2 3s for columns 4 and 5. So there is no more 3 inside here. Awesome, right? And the moment you eliminate 3, you have to eliminate 6 as well, because now 10 is not 1, 3, 6 anymore. It would have to be 1, 4, and 5. Superb. And now the moment you establish this box, you will notice that you form a pair of 4s across boxes. So 4 is eliminated from this box. You have 5 already from 2 plus 3, and you need 11 more, which cannot be 2, 9, 3, 8, which cannot be 4, 7, because quota of 2 4s is achieved. So it would be 2, 3, 5, 6. What a gorgeous interplay, right? Look how these 3 boxes got fulfilled, guys, right? Really? I mean, if there is a Miss Universe title for a Sudoku, then this Sudoku should get that. Beautiful, guys. Just look at how these 3 boxes played among themselves, and then we got those numbers. It's simply magical, really. And no wonder that the author had even mentioned this statement that you may feel weird while solving this, and you will feel that suddenly numbers begin to appear magically. That's really true. So we got this box now. And focusing on box 2, you have 2, 3, 5, 6, 9. So we need 1, 4, 7, and 8. Of course, 4 cannot be in these 2 cells. So 4 goes here, and that gives a locked pair. This becomes 1, 4. This becomes 7, 8. So 7, 8 gets eliminated from here. And remember that there must be an 8 in these 3 cells because of the 28 total. Now 8 has only 1 cell, so 8 goes here. So we got 17 from here, and it cannot be 4 plus 7 anymore because 7 is here. So this would have to be a 5 plus 6. Okay, so we are getting close here. Now, if you look where the 8 goes in box 1, 8 would have to be in these 3 cells. And you can easily obtain that 8 cannot go into the white cells. The reason is you have a 26 cage, and you also have a 9 outside the 26 cage, which sum up to 35. So basically these 3 cells must add now to 10, right? Because the sum of any row, column, or a box in a 9 by 9 Sudoku will always be 45, which is just the sum of the digits from 1 to 9, which is equal to 45. So if I put 8 outside, then I won't be able to get 10 from these 3 cells. I'll get a total in excess of 10. So that means 8 goes here. It has to go inside this cage, right? And now, okay, and now it's time to see how these boxes interact. Right, we saw earlier how these boxes interacted and got digits magically. Now let's see how these boxes interact, right? So for now, I'll remove this 9 from these 2 cells, right? Because it's kind of distorting the vision of this figure, right? We'll remember that 9 must be in here. So we need 9 more from 3 cells as far as the 18 is concerned. So there are 3 options for the 9. It can be 1, 2, 6, it can be 1, 3, 5, and it can be 2, 3, and 4. Let's see what happens if this is 1, 2, and 6, and 9, right? Let's put 1, 2, 6, and 9. So we know that there is a 1 and 2 here. We know that there is a 1 and 2 here. So which means 1 and 2 gets eliminated from this box. So the minimum total becomes 3, 4, 5, 9. And you will see that they are well above 19. 12 plus 9 is 21. So there is no way to make 19 total here if this contains 1, 2, and 6, right? So 1, 2, and 6 is eliminated as an option for the 9 total. So now let's look at 1, 3, and 5, right? So this was also a moment where I was briefly stuck yesterday. I was wondering how to continue here until I got the idea that, okay, this Sudoku has to work out this way because columns played their part. So now rows would have to play their part. And this is the point where I took a bit of time to make the elimination. 1, 3, 5. So the moment you have 1, 3, 5 here, 1 gets eliminated from this box, right? 2 ones are in here. 5 is also eliminated, right? And now how can you get to 10 from 3 cells? We already have a 9 in these 2 cells. We need 10 more from 3 cells. How can you make a 10 without a 1 and a 5? There is simply No way possible to get to a 10 without a 1 and a 5 from 3 cells. This was the thing which took me a bit of time. So the simple way to understand this is the minimum total now it becomes a 2, a 3, a 6 and a 9, right? Because 1 and 5 are already eliminated from here. 1 and 5, 1 and 5. So these rows don't contain 1 and 5. So the minimum sum becomes 2, 3, either you can have 4 is possible, right? I left off the 4. It's either 2, 3, 4 and 9, which gives you 18, or it is 2, 3, 6 and 9 because 5 is already eliminated, and which gives you 20. 2, 3, 6 and 9 is, sorry, it's how much is that? 9, 11, 20. Yes, 2, 3, 6 and 9 gives you 20. So there is no way you can get to 19 from 3 cells without a 1 and a 5, right? So which means that I'll remove these. 1, 3, 5 is also ruled out. We already ruled out 1, 2, 6. So the only option left to us is 2, 3, 4. Awesome. So 2, 3, 4 and 9. 9 is not here and 2 is not here. And now we can use some more interplay. 2 is in these 2 cells. So 2 is not in this box. And 4 is common between these boxes. So 2 and 4 is not in these cells. So which means you have a 9 here. Let me make that 9. 1 must definitely be inside, because if you don't have 1, then the total becomes well in excess of 19. So 1 is definitely inside. So we have a 10 now, and we need 9 more from 2 cells. It cannot be 1 plus 8. It cannot be 2 plus 7. It cannot be 4 plus 5 because you already have 4 common here. The only option left to us is 3, 6. So 1, 3, 6 and 9 is the only way to make the 19 kg. Just gorgeous, guys. Absolutely gorgeous. Really. Well done, Memeristor. Awesome Sudoku. This is such an awesome killer. I mean, and it's very difficult to produce such novelties in variants which have already been explored so much. And this is such a wonderful killer Sudoku. So we now know this is 1, 3, 6 and 9, right? And 9 is not here. So you have 8 here. So 8 goes in here. 8 is not here. 8 goes in here. 8 is not here. 8 goes in here. Okay. Look at this box. Box 4. So 18 kg and the 15 kg give us a total of 33. So which means these two cells must sum up to 45 minus 33, which is equal to 12. And 12 has only 3 options. It's either 3 plus 9, which is ruled out because 3 is inside the box, or 4 plus 8, which is again ruled out. So that leaves us with 5 plus 7. This is the only option left to us. And now we know the contents of this cage. We can simply put them. They must be 1, 6, 8. 8 is not here, so 8 goes in here. And now the 8 in this box, due to classic, goes in here. Of course, 8 cannot be here because of this. And now look at this 27 total. It becomes forced. The moment you eliminate 8 outside, the maximum sum you can get from 3 cells is a 5, 6 and 7. And if you now add all these cells, you will get exactly 18. That leaves just enough room to get us to 18, right? So this becomes a 5, 6, 7. So we have a 5, 6, 7 triplet here, which means this 6 can be eliminated from here. So that's 1 and 8. And that becomes a 6. This is not a 6. It's a 5, 7. Okay, 6 is not in row 6. So 6 goes in here. And that gives us a locked pair. Gorgeous. That's simply gorgeous. So 6, 8. And now we can write the pencil marks in here. They must be 3, 7, 9. Without the 9 here. And we know that there is a 3 in column 4 and column 5. So 3 gets removed from these 2 cells. That becomes a 7, 9. So that is a 3. And that 7 resolves this 5, 7 pair, which resolves this 5, 6 and 7. That becomes a 5, 6. Okay, so let's look at column 1. 5, 6, 1, 7, 8, 9. So we need 2, 3, 4 from these cells. And okay, 8 is in these two cells, right? So this is not 8. That could have been marked a bit earlier. That becomes 1, that becomes 8, and that resolves this 8-6 pair, removing the 6 from here. And okay, now where does the 7 go in box 6? It can't be here, cannot be in row 6, so this would have to be here. So 3, 7, 9 and 1, 5, 6. So this becomes a 2, 4, 8 pair. I'm sorry, 2, 4, 8 triplet, and that forces the 4 in here. The only possible digit now left in box 6. Okay, so we can look at this 10 cage now. Two cells which form 6, which doesn't have a 4. There is only one possible way. Oh, I'm sorry, what mistake? Okay, this is not a 4, right? 2, 4, 8, 1, 3, 6, 7, 9. This has to be a 5. And now let's continue. Okay, this 5 resolves this 5, 6 pair. That's a 5, that's a 6. So column 6 can be filled. It's just there like a sitting duck. So 3, 6, 8, 9, 1 and 4. So this becomes 2, 5, 7 without the 7 here. And that becomes a 6, 8 pair. And 5, 6 can be resolved. So that is a 6, that is a 5. Because you have a 6, 8, this could be resolved. And that 5 resolves this cell. That becomes 5, 7 now. Okay, let's put some pencil marks in row 9. The remaining digits must be 1, 3 and 4. Okay, where does the 5 go in column 2? Only one cell left. 5 would have to be here. Removing the 5 from these cells. Okay, the 7 in column 3 has 3 options. And this is not possible, so this is removed. So 7 goes in one of these two cells. Okay, even the 6 follows the same one. So 6 goes in one of these two cells. So this becomes a 6, 7 pair, right? And now time to revisit these 3 cells. We earlier saw that these 3 cells add up to 10, right? And 6 is quite a high number, even 7. So regardless if you have 6 or 7, 1 must always be inside these 3 cells. If it's a 6, it becomes 6, 1, 3. And if it's a 7, it becomes 7, 1 and 2. So there is only one cell left for the 1. So 1 would have to go here. Now it's either 6 plus 3 or 7 plus 2. 4 is eliminated. That's 2 and 3. Okay, so the moment I got this pencil mark, these came into life. So we need 5 from 2 cells, which is 1 plus 4 or 2 plus 3. Now 2 plus 3 is ruled out because we got 2 plus 3 here, right? So this has to be 1 plus 4. Awesome. Fantastic. So this becomes a 2, 3, 7 triplet for the box. Okay, we can resolve this 1, 4. It's 1 and 4. And 4 now in box 1 has only one option, can't be here and cannot be in any of these cells. 4 goes here. And this becomes a 2, 3 pencil mark, just like this cell. This is also 2 and 3. This can't be 1. Just tidying up the pencil marks here. So there is a 1 in here. And looking at column 9, there is a 3 in here because 3 can't be in any of these cells. And that leaves as a really nice reduction. 3 is removed from these cells, box reduction. 3 goes up from here, giving the 3 here, giving 2 here, 3, 2. And now we know the contents of this cell. This would have to be a 6. That becomes 7. That is not 7. That's 2, 3. So 7 goes here. And this can be resolved. Can't be 3 and 6. That's 2, 5. And that 3, 6. And that resolves this 2, 3 pair. That's a 3. That's a 2. look at the way these middle columns are setting up, guys. It's just so gorgeous to look at, right? I wonder, you just look at the finish. This is really special. 2 6 9 3 5 7. You have a 1 here, so that is 1. That becomes a 4 8 pair, and that resolves this column. This becomes 2 9 pair. That becomes a 3 4 pair for the column. And you have a 2 here, so 2 can be resolved. That's a 2, that's a 9. And that gives us the 9 in this box. That's a 9. 1 3 6. 3 can't be there, that's 1 and 6. Okay, because of the 9, we can remove the 9 in here. Okay, you have a 1 4 pair in here, right? And now in column 9, where does the 1 and 4 go? They can't be here. So they would have to be in these two cells, 1 4, which means this cannot be a 2, right? That's a 4, that's 1, that's 4. This becomes a 2 8 pair. And 2 8 can be resolved, so that's 2, that's 8. 1 4 can be resolved because of this 4, that's 4, that's 1. And this becomes 2 3 pair for the column. You have a 2 here, so that's a 3, that's a 2. Okay, 1 in here finishes off this box, so that's a 1, that's a 3, that's a 6. And this column can be completed with 7 8. And this column can be completed with 5 6. So I have a 1 and 3 here. So this is not 1 and 3. That becomes 4 and 9. And 4 is removed from these cells. That becomes 1 3. Look at the Sudoku, guys. I mean, a perfect and clean as a whistle construction by Memeristor. Awesome. Just look at these pencil marks by value candidates. Amazing. I mean, the finish is so spectacular. Okay, you have a 6 here, which means this is 6, this is 5. That's 5 7. That's 7 8. 8 4. And now coming on to the middle column, you have a 3 here. So that's 3, that's 4. So this gets resolved now. So that's a 4. This becomes a 1 5 pair. Now look at the finish of all these stacked up digits, guys. This is just a perfect example of a finish in a Sudoku. So 4 gives a 4 and a 9 here. A 9 and a 7. 7 8. 8 6. 6 3. 3 1. 1 5 5 2, and that's good, the timer says. So what a jewel of a construction, what an amazing killer Sudoku. I would rate this 10 out of 10. Such a beautiful killer Sudoku by Memeristor, definitely deserved more attention, and that's why I thought of making a video on this. So hope you guys enjoyed watching me solve this beautiful and hard killer Sudoku. Once again, kudos to the author, Memeristor, for creating such a beautiful construction. I really enjoyed making a video on the Sudoku. Thanks for watching. Please leave a comment and subscribe to the channel. We will see you soon again with a video. Bye-bye.